Hello guys, welcome to this channel. In this video we are going to see in an infinite square potential how to find the expectation value of energy. So this is the question. So the first thing is you have to identify the system, and the other thing is the asymmetric is involved. So the 0 to something case. So if asymmetric, the wave function is always be in the concept of sine. Okay, so here you can see in unsymmetric case the wave function will be in two forms, that is depend on odd and even value, but in the asymmetric case without any doubt it will be in a sine form. Is prepared in a state with a wave function, that is a wave function given to you. A sine cube pi x by a is the wave function given to you. So the expectation value of the energy of the particle is, so there is a two concept in this question. One is a system is involved and the other is expectation value of the energy. So there is a two different formula to tell the expectation value of the energy. So one is the expectation value will be equal to integral minus infinity to infinity. No restriction or nothing else is given. So take complete range. The into psi star and energy operators into psi d tau upon integral minus infinity to infinity psi star psi d tau. Instead of writing in terms of integration, you can write it this expression in this way, that is psi e psi upon psi psi. Both the expressions are the same. Either you can write it in this way or you can write it in the integral form also. Now you need to know when you will be using this one, or there is one more where you will be using that one. So basically the wave function will be given to you in the form of exponential, or the wave function will be given to you in the form of just one expression which is a function of something, just one expression like sine x or cos x or sine square x, something like that. So which is the expression, you can write it in the form of a psi 1 plus b psi 2. We cannot write it in the superposition of two different state wave function. If this is the case, you can avoid using this formula. Instead of, you will have another one, that is if you have to find the expectation value of energy when the wave function is in the superposition of two different state wave function. So in that case it will be simply summation n en pn. For different n value it will have different energies. Same way here you will be writing the energy for corresponding state, energy for one state and probability of finding that particle in that state, plus the energy of another state and the probability of finding the particle in that particular state. Probability will be favorable one coefficient square upon sum of square of all the coefficient. Favorable means what? To find the probability of finding the particle in the state 1, because psi 1 is there, so that the wave function coefficient or that expression coefficient, you will take it as a coefficient. You will write it the square in the numerator and take the modulus, and upon sum of square of all other coefficient and take the modular. This is how you will be considering it. Okay, for p2, the square of that favorable one, that is b square, and take modulus upon all the sum of square of all other coefficient, a square plus b square, and take a modulus for both. Now everything is depends on one factor, that is what kind of wave function has been given. It is a kind of a wave function which is superposition of two different states wave function, or is it gonna be a just common expression? Depending on that, we will do the selection of formula for expectation value of energy. Okay, now we know sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Here I replace sine cube theta with the expression. So it will be, I will find sine cube theta from here and substituting that in wave function. So now the wave function will be a, and inside the bracket we will have sine cube theta is there. For sine cube theta, take it on the other side and take this on in this side. We get 3 sine theta will be pi x by a. So 3 sine pi x by a minus sine 3 pi x by a. So you will have 4 in the denominator after simplification. So I will take it that in outside. So this is the wave function I got, or a sine cube theta expression can be write like this. So it is the form sine n pi x by a. So n will be 1 and 3. So what was the length of the potential? That will be A. So the length is correct. So the form we are getting is same as the wave function form. So what term will be missing here? Root 2 by L. Here the system is asymmetric form. So the wave function of the asymmetric will be root 2 by L sine n pi x by L. This is the standard form. So now multiply and divide it with root 2 by a. Okay, now in this case root a by 2 will be remaining, while root 2 by a will be included with the sine term. That will be give psi 1x, that is the wave function corresponding to the value n is equal to 1, and then here we have psi 3x. This is what we have got. Here we have the combination of two wave function. So the expectation value of energy will be what? Summation n En. So let's write energy for the first state, that is n square pi square h cut square by 2m L square. Here n will be equal to 1. What is L here? That is A. Okay, the length of the system. Then the probability of finding the particle will be some coefficient square upon sum of square of all the coefficient, that is 9 upon 10. So the another state energy will be 9 pi square h cut square by 2m a square, because n is equal to 3. Now the probability of finding this particle in the state will be 1 upon 10, that is the coefficient square upon sum of square of all the coefficient. So what you will get is 9 upon 10, you get twice. So 2 into pi square h cut square 9 upon 10 ma square, and 2 cancel out. So simply 9 upon 10 pi square h cut square upon ma square, that is option C. It will be the correct one. So that's how you have to approach this type of question. That's all for today's video. Thanks for watching and subscribe to my channel. If there is any doubt, please comment below. I will be check it out and make sure to clear all your doubts in next video.